Bem-vindos ao nosso espaço, um mergulho profundo nos assuntos mais interessantes de esportes, ciências e temas gerais do momento. Aqui você vai encontrar conteúdo de qualidade, com análises empolgantes e descobertas fascinantes que vão expandir seus horizontes. Nossa missão é trazer informação relevante de forma dinâmica e descontraída. Queremos que você faça parte dessa jornada incrível de conhecimento e diversão. Se gostar do nosso conteúdo, não esqueça de deixar seu like e se inscrever no canal para não perder nenhuma novidade. Ative o sininho também. Aproveite!
If you love science, don't forget to like and subscribe. Neptune is a world of superlatives. The windiest planet, the outermost giant, and perhaps most mysterious, the owner of the most bizarre magnetic field in the solar system. Unlike Earth's field, which acts like a smooth bar magnet aligned with the planet's rotation, Neptune's field is violently tilted by about 47 degrees and significantly offset from its center. If Earth's magnetosphere looked like Neptune's, compasses in New York would point toward South Carolina. This chaotic arrangement is more than just a curiosity. It suggests that the engine generating this field, the planetary dynamo, operates under conditions we cannot find anywhere else. Conditions dominated by a truly exotic material, Superionic Ice. To understand Neptune's invisible magnetic shield, we must first look past the blue atmospheric haze. Neptune is classified as an ice giant, and the term ice here is highly misleading. It doesn't mean frozen solid water like the ice in your drink. It refers to volatile compounds, water, ammonia, and methane, which, under the immense pressure and temperature of Neptune's interior, transform into dense, scorching hot fluids. Below the thick hydrogen and helium atmosphere, the pressure rapidly increases, exceeding the surface pressure of Earth by hundreds of thousands of times. This colossal compression heats the volatile mantle to temperatures that can reach 5,000 Kelvin, hotter than the surface of the Sun. It is in this high-pressure, high-temperature environment that ordinary water takes on an extraordinary form. Scientists call it Superionic Ice, or Ice 18. Imagine the oxygen atoms of water locked into a rigid, crystalline lattice, a solid structure, much like normal ice. But the immense thermal energy prevents the hydrogen atoms, which are now stripped of their electrons and exist as bare protons, from remaining bonded. Instead, these positively charged hydrogen ions begin to flow freely, diffusing and moving throughout the fixed oxygen lattice, behaving like a highly conductive liquid metal. This is the Superionic Ice trap. The material is structurally a solid, but electrically, it is a liquid conductor. And this is the key to Neptune's magnetic field. Standard dynamo theory requires a flowing, electrically conductive fluid to generate currents strong enough to create a magnetic field. In terrestrial planets like Earth, this conductor is molten iron in the outer core. But in Neptune, the mechanism is fundamentally different. It is the movement of these highly mobile, superionic hydrogen protons within the mantle that generates the complex electric currents needed to power the dynamo. So, why is Neptune's field so weirdly tilted and non-dipolar? This is where the confinement of the Superionic Ice comes into play. In planets with a large, deeply central conductive core, like Earth or Jupiter, the generated magnetic field tends to be dipolar and aligned with the spin axis. This is because the massive core smooths out the chaotic fluid motion. However, simulations suggest that the layer of superionic material in Neptune is relatively thin, existing as a broad, conducting shell located far from the planet's center, close to the surface mantle boundary. Crucially, this exotic, conductive shell is subject to strong convective turbulence, rapid, churning movements that constantly shear and distort the magnetic field lines. Since the dynamo is operating in a shallow, turbulent, off-center region, it cannot stabilize into a clean, simple dipolar field. Instead, it generates strong multipole components, quadrupole and octupole fields, resulting in the observed chaotic, tilted structure. This revelation about Superionic Ice wasn't just pulled from theoretical models. Breakthroughs in high-pressure physics, utilizing tools like the diamond anvil cell, have allowed researchers to squeeze tiny samples of water to pressures found inside ice giants. By heating these samples with powerful lasers, Scientists have directly observed the moment water transforms into its superionic state, confirming its extraordinary conductivity. This deep space secret has massive implications not only for Neptune but also for its twin, Uranus, which exhibits a similarly bizarre magnetic field. Understanding how superionic matter dictates the magnetic geometry of these ice giants is critical for evaluating their internal heat flow, atmospheric stability, and even their potential to harbor internal, liquid water oceans, a critical factor in the search for extraterrestrial life. The Superionic ice trap proves that the physics operating inside our outer solar system neighbors is anything but ordinary. It is a realm where water acts like metal, solids flow like liquids, and exotic states of matter define the very boundaries of the planet itself. For more incredible facts like this, don't forget to subscribe and turn on notifications.